Hello, everyone, and welcome to our talk on explainability for text summarization of legal documents. My name is Nina, and we'll be presenting today to you together with my colleague, Milda. Before we dive into the topic, we would like to briefly introduce ourselves. Milda, would you like to go first?
Sure. Thanks, Nina. So hello, everyone. My name is Milda. I'm a senior designer at Thomson Reuters Labs in Switzerland. And my focus is figuring out the human side of the AI solutions. For example, how and where to put the human in the loop in the AI solutions that we build, how to get them to trust the models, and similar topics.
And I'm a data scientist in the same team as Milda. And my focus has been on text summarization, both extractive and abstractive, and also named entity recognition. And now that we said that we are both working at the labs, let us briefly introduce also the labs. So Thomson Reuters Labs is the applied research division of Thomson Reuters, and we're a global team with locations in North America, Europe, and Asia. And we're a team of data scientists, engineers, and designers. And now onto our agenda for today. So I will talk about explainable AI and our use case at Thomson Reuters, where we applied explainability. And then Milda will talk about explainability for text summarization, and we'll come back together for the key takeaways.
All right. So the first thing that we'll talk about is explainable AI. So what is explainable AI and why do we need it? Explainable AI is an emerging field in technology, and it's really an umbrella term for a range of techniques, algorithms, and methodologies which provide outputs from AI systems with explanations. And this addresses this undesired black box nature of more complex machine learning models, such as, for example, deep learning models. And we believe that explainable AI would really be the key in the future adoption of AI models in production. Who are the main user groups? So explanations for whom? We have three main user groups that you see here on the screen: the AI system builder, the end user, and the regulatory body. So let's start with the AI system builder. These are people like me, for example, a data scientist. And when I'm looking at the model and its outputs and its performance, and I'm asking myself, okay, is the system working as expected? How can I improve it? Then we also have the regulatory body. So the idea there is, okay, are decisions made in a safe and a fair manner? Does the model comply with the legislation? So, for example, we already see GDPR and other legislations that come into light around this. And last but not least, we also have the end user. So the end user, when they're using the system that has AI, they're asking themselves, okay, can I trust the model output? Can the model provide me with additional insights? And really what we'll be focusing on for this talk will be this center user, the end user, and we'll be talking more about that later. And next, we'll also talk about the two different types of explainability. One is model-specific and the other one is model-agnostic. So model-specific explainability, this is really, we get explanations derived directly from the model. So before we were able to do this mainly with with less complex models, such as, let's say, logistic regression or random forest, because we would have access to, for example, the probabilities that are inside, also decision trees, and in general, we would really know how the models within make the decisions. And then there's also model agnostic explainability, which is more of creating post hoc explanations. For example, they can be applied to any machine learning model, so both simpler and more complex, such as neural networks. And there are already some frameworks that exist and do such post hoc explanations. For example, LIME, SHAP, PDPs, and so on. And feel free to read more about them afterwards. But an example of such model agnostic explainability would be, let's say we have the outputs, and then maybe we measure some kind of similarity between the output and also what was the input to the model. And next, we would like to talk also about our use case and to introduce it before Milda goes into how we use explainability for text summarization. So let's start with the scenario. So we have a lawsuit filed to the court. A lawsuit is usually a legal case. This legal case is 10 to 100 pages long, so the length varies. Then we have editors, team of editors that read this case and then summarize it. And then at the end, we have legal firms that read those summaries and choose who to represent. So we're really focusing here on the second step. Editors summarize the lawsuit, because we wanted to see whether we can somehow help our editorial teams in their processes for summarization. So can AI help in there? And this is just an example of how the editorial tool used to look like. So the editors would have the blank boxes on the left-hand side that they have to fill in from scratch. And then the legal case, they can view in PDF on the right-hand side. And for us as data scientists, this data was really exciting because first, it was quite a lot. We had an abundance of it. And then second, it was very clean. So we had about 1 million pairs of court cases and their corresponding editor-written summaries. From which we could, so the court cases are our source and the editor-written summaries are our target. So as we said, the legal cases were the source. They would come from PDF OCR, raw text. And then after talking to our editors, we found out that the first 10, 15 pages actually contained most of the important information for the summaries. So our targets were 1 to 2 sentences long, which might not seem a lot, but for a machine to actually generate coherent and consistent text that is 1 to 2 sentences long is actually quite challenging. And also we had the information that it takes about an average of 6 minutes to write those summaries from scratch. Right. All right. So we know about our data. Now let's look into what type of summarization model should we be looking into. So before we establish that, we have to figure out, okay, what are our editor-written summaries? Are they more extractive or abstractive? What I mean by that, I would like to show with an example. So let's say our source is here on the screen. The sun was setting on a beautiful autumn day in October. Ricky was lying lazily in the garden when a quick brown fox jumped over him. Ricky is my best friend and our beloved family dog. So an extractive summarization of this would be a quick brown fox jumped over him. So here it's extractive because words and phrases and even the whole sentence is taken directly from the source. An abstractive version of it would be the fast brown fox jumped over the lazy dog. So here the words and phrases are not all identical to the source text, but we kept the same meaning. So this is a bit more of a human-like summary, where we would keep the meaning but use novel words. So when we can actually measure what our editor-written summaries are more like? Are they more extractive or more abstractive? And when we did that, we found out that ours are somewhere in the middle. So when we were trying to choose a model, we chose a model that would do both well. So both extractive and abstractive summary. The model that we chose is called the Pointer Generator Network. If you'd like to read more about it, you can scan the QR code on the top right corner. And under the hood, it's a bio-LSTM. So what makes it good for extractive and abstractive summarization is that the pointer extracts words from the source text and the generator abstracts what goes into the output, so to the target. And the pointer also aids the factual accuracy of the summary, which is very important for summarization. And then the generator retains this ability to generate novel words. Another part that is also in the pointer generator is this attention mechanism. And what, in general terms, what attention does is that it really draws dependencies between the input and the output. So it would draw dependencies between the source and the target. And how this works on a more granular level is that if we look at what we have in the screen on the screen here, we can see that, okay, so the source are the words in the source are the tokens in red. Then we have the model is generating right now on the right the word in yellow, so the word beat, which is in the partial summary. And then if we follow the arrows to the blue distribution, to the attention distribution, here we see that for this word beat, it has an attention score or an attention value for each word in the source text. And this is how the attention matrix or the attention mechanism is created and stored, and it's used by the model to improve its performance. So it was first introduced in 2016, this concept, and it was really the mechanism to allow a model to automatically soft search for parts of the source sentence that are relevant to predicting a target word. And then in 2017, followed the article Attention is All You Need, which introduced the attention mechanism officially and also the transformer models. So currently the models that use this attention, the models for summarization that use this attention mechanism are on top of the leadership boards. All right. So now that we know a bit about the architecture of the model that we used, let's go into the evaluation. So what we did for evaluation is something called double-blind evaluation by human experts. So we created this experiment where we would show a number, we would show multiple editors, the same summaries, machine-generated editor written as well, and they would say whether they are publishable, somewhat publishable, not publishable, and maybe some other categories. But in general, what we're showing here on the bar chart is that the percent of documents that were deemed as publishable. So what's interesting here is that the editor-written summaries are not 100% publishable, or not all of them at least. And then if we look at the machine-generated ones, they're, of course, not as good as the editor-written ones, but they're getting pretty close. So this model was put in production, and this is how the editorial tool looks like now. So now instead of on the left-hand side where, if you remember, were the empty boxes, now there is a pre-populated field where the summary sits. And the editors, instead of writing a summary from scratch, they have to validate the summary that they see in this box. So we did, again, time studies, and we saw that from 6 minutes on average per summary, now the summaries take about 3 to 4 minutes on average. And this was already a very good gain in terms of performance and aiding the process. But when we were really looking into this, we were thinking, okay, can we somehow add more value to this? Can we perhaps use the attention mechanism? And for example, one way to do so, what we can get from the attention mechanism here is that, so we can normalize the vectors that we get per word in the target. We can normalize those vectors and actually get attention scores for the whole summary per word in the source text. So here, what you see here is that the squares that are with higher intensity, this actually means that the attention score is higher. So perhaps maybe we could use some highlighting. But I'm not going to go into more details about that. And I would leave you to Milda to introduce you what we did next.
Thanks, Nina. So why did we turn to explainability? Well, after building the model and starting to test it with the editors while working on bringing it into production, one of the things we heard the editors say was that they felt they still had to look at the whole court case to verify the summary that was generated by the model, and that it would be nice to see what the model looked at while generating the summary. So we were curious whether we could enhance their experience by adding explainability features to the summary review process, and more specifically, if the explainability could reduce the time spent on validating the summary, and if explainability could help to increase the editor's trust in the AI system. We experimented with two explainability methods. The first one was the attention vector approach, which we called attention highlights. And it used the attention scores produced by the model at the time of prediction to show which parts within the input text did the model pay attention to while generating the summary. This then results in different intensity of text highlights, where darker blue means that the model paid more attention to that part of the text, and lighter blue means that the model paid less attention. The second method was called the source attribution approach, which we named source highlights. And this was a model-independent heuristic to identify one or more sentences in the input text, which the summaries language primarily came from. And because here the text either had influence on the summary or it didn't have an influence, we only have one intensity of blue in the highlighting. To test these approaches, we built an interface which mimicked the tool the editors actually work in, minus the details that were not relevant for this specific study. So here you can see what it looked like for the attention highlights condition. On the left, there was the summary generated by the model. In the middle was the case text. And then on the right, we had a scale explaining how to read the highlighting. And we also came up with what we call the page picker, where we displayed which pages the model paid the most attention to. So the users could directly jump to that page if that is what they wanted to do. Then for the source highlighted condition, it looked very similar with, of course, the highlighting only having one shade of blue as previously mentioned. The scale was on the right was modified to present what the highlighting meant to the users. And with the page picker, we noticed that with the source highlighting, typically there were only one or maximum two pages that had text that was relevant to the summary. And again, the users could go directly there using the page picker if they wanted to do that. Then finally, we also had a control, no highlighting condition. And again, the interface elements were very similar, but of course, since there was no highlighting, there was no scale, and the page picker had no color. So we had 2 rounds of testing in total, and in the first round of testing, we tested attention highlights, against no highlights. And this was what the experimental outline looked like. So we tested with 2 editors in total, and they both were timed in the background without being aware of that. So the first editor reviewed the 11 cases with attention highlights. And after that, he worked in no highlights condition, where he also reviewed 11 cases, but those were different cases. And all of that was followed by an interview. Whereas the second editor started with no highlights condition. So this was important to ensure that the order of the conditions had no influence on the performance of the editors. And then after that, the second editor worked in attention highlights condition. And then the cases that the second editor saw in the no highlights condition were the same cases that the first editor saw in attention highlights condition. And this ensured that we always had a control for a highlighted case, but it also meant that none of the editors saw the same case twice. Using the same setup, we then 3 weeks later conducted a second round of testing, where we tested the no highlights condition against the source highlights condition. Now, moving on to the insights. There are 3 key insights that we wanted to share with you, namely on time on task, trust, and about the usage of highlights. So starting with the time on task, as you can see on the left, we learned that the editors, when working with attention highlights, were significantly faster reviewing the summaries than when they worked without the highlights. However, as you can see on the right, we didn't find such a clear effect and how the source highlights impacted their performance when reviewing the summary. And the interviews helped to clarify why this was the case. So in terms of trust about the source highlights, the editors have said, do I just trust that one section that was highlighted? It doesn't feel like I've done my full job as a reviewer. And sometimes I spent more time making sure that one section was correct. Whereas with the attention highlights, the different shades of blue for the document that it had gave them a sense that the AI system did look at the whole case. So even if it got it wrong, it made the editor trust it more. And in terms of how the highlights were used, the source highlights were used as a way to get to the area of the document where the relevant details to the summary might be. However, they weren't always really the relevant details, and the editors had to find them themselves in the end. Whereas attention highlights, the darkest blue, gave them this relevant detail, as well as the lighter blue sometimes conveyed additional information that the editors have chosen to add to summary, which was helpful to them. And in addition to that, one of the editors have said that apparently there was a time when the summary has said that the case was a car accident case, whereas it was actually an insurance case. And so in that case, the attention highlight and even helped them to correct the summary. So we actually published a case study about this experiment, and it has even more details about our learnings. So I would recommend you to read it if you're interested in learning more. Okay. All right, so now let's move on to key takeaways from the session. Nina, over to you.
In the beginning of this talk, we learned that explainability is becoming a crucial player for the future of adoption of AI systems. And we also took a brief look at the 2 main types of explainability with relationship to the model, model-specific and model-agnostic. In our use case at Thomson Reuters, we saw that we augmented the task of our users. Now, instead of writing a summary from scratch, they are validating one. And this is where the question of how can we increase trust in the machine-generated summary came in, and how can we use explainability to do that. We also saw that the attention mechanism in deep learning models can be used for model-specific explainability. Milda, back on to you.
Yes, so from testing two different explainability approaches, one of which was attention mechanism, we learned that explainability can create measurable benefits in terms of time savings. And that well-chosen explainability methods can enrich interactions between AI system and the user. However, for that to happen, the explainability methods have to be designed to task. And finally, we believe that more attention should be given to model-specific explainability methods within the research community. So we hope that you enjoyed today's session as well as learned a lot from it. Please do not be shy to find us on LinkedIn as well as tweet at us with your key learnings. Thank you for being here today.
Thank you and have a great day. Bye-bye.